Hello, in this video we're going to learn how to create holes on our parts and how to read hole notes off of our drawing sheets. First of all, let's talk about the different kinds of holes we might be needing to create. First kind is a through hole, and this just simply means your hole goes all the way through the thickness of the part. A clearance hole is where you define a diameter of the part that needs to go through it, and then it makes the hole just a little bit larger so that the hole screw or even the screwdriver can pass through the opening that you make of the hole. A blind hole means it doesn't go through the entire thickness of the part, that it only goes partway down. Countersink holes have a conical tapered head at the top so that your screw can go into the part and go far enough into the part that the top of the screw is flush with the top of the part. A counterbore has the same idea, only the top of the screw is a rectangular shape, and this is so that you can put a bolt or a nut head inside, so it has a thicker, more rectangular shape for the top. And again, we do that so that it can sit flush with the top of the part. And then a tapped hole, that just means we put threads on the inside of the hole so that as we screw in the screw, they can mesh with the threads of the hole, and then that creates more friction and makes just a little more secure part. Here are some common symbols that you're probably going to see on your drawing sheets. This symbol right here means diameter, so this is how wide we need to make the hole. Notice this looks like the top of a counterbore hole, and that's exactly what it means, is the counterbore symbol. Here's a symbol that looks like the countersink, the top of a countersink hole, and that's exactly what this means. We want to make the top of the hole have a countersink. And then this one is really, really important. This tells you how deep. So if you want to make it a through hole, you won't usually see this symbol. You'll just see the words through after your diameter symbol. However, if it's a blind hole and it only needs to go a certain depth into the part, you'll see this symbol that will tell you how deep you need to drill that hole. So now let's take a minute before we start looking at blueprints and drawings. Let's take a minute and go to Inventor, and let's open my practice part file. So let's go to the R drive, pre-engineering. If you're in Broken Arrow, you're going to choose Hogan, but this is Mrs. Krumzik making this video, so we're going to go to Krumzik Bixby and IED, and then Broken Arrow, you'll go to IED for Miss Hogan. Both groups go to Unit 5, and then Holes practice part. Now, in order to create holes, because we have this feature here, and hopefully your Inventor expert has talked to you about this already some, we need to have points on here so that we can use those reference points to drill the holes. So I'm going to create a 2D sketch on the top face of this part. And then I'm going to come up here to my point and draw, and I'm going to grab a point. And we're going to have 6 different examples, so I'm going to put 6 different holes. Just randomly spaced out here. And then hit escape. And I can move this point over if I want some to make sure that I have enough space for all of the holes that I need to drill. So we're going to have 6 examples, so I put 6 points, and I'm going to finish my sketch. Now, the parts that we want to, the hole is a 3D feature, so I really need 3D points. So now I need to come out here to the 3D point feature, and I'm going to use these work points, and I'm going to place them right on top of my 2D points. So I'm clicking the point, and then I'm saying I want it to be a 3D work point. And now our part is ready to go. We're ready to start looking or making some holes into this part. So I am going to minimize this for a minute. And I'm going to come back to the PowerPoint. And let's look at the next blueprints. So these are hole notes. These tell me exactly what kind of hole I need to drill. I notice that I see this counterbore shape, so that's the kind of hole that I need to drill. The diameter of the shaft of my counterbore hole needs to be 0.25 inches, and I need to draw that at a depth, a blind hole. It's only going to go 0.75 inches deep into my part. The diameter of the counterbore at the top needs to be 0.38. Notice that it's bigger than the shaft. And my counterbore, how deep down I need to make the counterbore, is shown by this symbol right here. It's going to be 1/4 of an inch. So let's look at these notes. Oops. Did the wrong thing there. Let's look at these notes and let's make that hole over here on this part. So I'm going to come over here to the Modify tab and I'm going to choose Hole. And over here, instead of from a sketch, I want to put it on a point. I want a certain hole on a certain point. So I'm going to pick point and I'm going to pick my first point right here. And then it wants to know what direction do I want to drill it. So when I'm here, I'm going to click on this axis that appears. Excuse me. Now, when I'm looking at my thread notes right here, I want the diameter of the shaft, this shaft right here, to be 0.25. So I can come over here and type in 0.25. But I want a counterbore hole, so I'm going to come over here and click on counterbore. And so now I want the counterbore's diameter, this diameter right here, which I notice goes right here and is here, I need that to be 0.38. Oops, and I have 2 decimal places, so it turned red. And then the depth of that counterbore, how deep, so notice this right here, how deep, needs to be 0.25. And right now I'm showing drilling the counterbore all the way through my part, but this said I want it only drilled 0.75 inches deep. So I'm going to come down here to termination, and I'm going to click on this drop down arrow, and I'm going to say I want to drill it a distance. And I don't want that distance to be an inch. I want it to be 0.75 of an inch. And then I'm going to click apply. Oh, notice over here on the side, that's all that these notes tell me to do. But I do have choices down here where it can be a simple hole, it can be a clearance hole, so this is where you get a little bit extra between the diameter you choose and the hole. Or it could be a tapped hole where we put the threads in. But for right now, I just want to have this counterbore hole. Also notice here on the drill point, you can have it flat or you can have it angled. Angle is usually the natural choice because when we put a drill bit onto this part to drill down into it, the drill bit has a tip that's shaped like this. So the bottom of the hole naturally ends up tapered. However, some applications require a flat bottom to the hole, and so you will see some notes and you can have this option to choose. However, we're not going to talk about it much because it's not very common, because it's not natural to drill this way. It is more expensive to create these kind of holes. So enough about that. Let's apply, and then I'm going to close out of this, and I can see when I rotate my part that I have a counterbore hole. And then I want to clean up my sketch, so that's work point 6. I'm going to right click, and I am going to turn the visibility of that point off. And then that point should, oh, I picked the wrong one, that's 6. Turning that visibility back on. I'm going to turn off work point 1 and turn off its visibility, and it cleans it up. And now I don't need my sketch anymore, so I can clean up the visibility for it as well. So there's my first hole. So back to the PowerPoint. We've just made this hole right here. So a lot of notes, but it's really self-explanatory, and it's just showing the options that you need to pick in that whole menu. So let's make another. This description is telling me I need a diameter of 0.38 inches, and I want to drill it 1/2 inch deep. So I'm having a blind hole with a 0.38 inch diameter. So back to Inventor. Again, modify, I want to make a hole. I want to make a hole on a point, and I'm going to pick my other point here, and I'm going to pick this axis for my direction. And then for this example, we just want a regular hole, so I don't need counterbore or countersink. And then I do want it to just go a distance, so I'm going to tell it a distance, and it's asking me what distance right here do you want to drill. We want to drill at 0.5, and then 2 points again, 0.5. And then this is asking me what diameter does this shaft need to be, and we need 0.38. So I'm going to come in here and do 0.38. And it really is that simple to get this hole on here. And then I can come over here and turn off the visibility for this work point. Let's try another. Okay, this thread note or hole note is saying that I need a diameter of 0.38 inches all the way through the part. So this is how you know that it needs to go all the way through. It says through. So I come back to Inventor, modify, I want to make a hole. I want to make a hole on a point. I pick the point that I want and the direction that I want it to be drilled. And this time we want, I want a diameter of 0.38 all the way through. So when I pick my hole here, I'm going to pick this, and I want the diameter to be 0.38, and it already has that because that's what we made the last one. And then instead of going a certain distance, I don't have to know how thick that part is. I just come here and I say through all, and it does it for me all the way through. And again, if I wanted to thread it, I could have this choice right here. If I said a clearance, then I would go here. And then I'm going to apply and get out of this, and then I want to turn that work point off. There's my through hole. Notice when I look through, I can see all the way through the hole. Okay, let's try a countersink. This notes on my blueprint shows me that I need a diameter of 0.5 all the way through the part. But I need to countersink the top with a diameter of 1 inch at an 82-degree angle, taper. So let's see what that looks like in Inventor. Again, I'm going to go to my hole feature. Now I notice that on my notes I have this symbol, so I'm looking for that shape. I want to create it from a point. So I come here, I want to create it on this point in this direction. And then up here it's asking me how wide do I want this top. I wanted the top countersink to be 1 inch, so I'm going to come up here and say 1. And then my taper angle is 82 degrees, and this is where I put it right here. Here's my taper angle. It already has 82 degrees because that's a standard for a screw. So we have that. And then I wanted a 0.5 inch diameter for the shaft that goes all the way through. So here I'm going to change my shaft to be 0.5. And again, down here at termination, if it says distance, it'll only go a certain way, but we want it to go all the way through. And then I click apply. And now you can see that my hole, cancel this, has that nice taper at the top, and it goes all the way through. And then I'm going to clean up that work point by turning off the visibility. So that's holes. That's how you make all of the different kinds of holes. It's really just clicking on different choices in that menu for the holes. Something else that we need to talk about are thread notes. Threads are the threads that go on the outside of the screw, or we can thread that inside of that hole, which makes it a tapped hole. They are dimensioned with the use of local notes. So we'll have little notes. Here's an example of thread notes in Unified National Thread Method, which is the English system. And here's an example of thread notes in ISO system, which is really the metric system. So let's look at how to read those. Notice here's your leader line. This leader is showing you what kind of threads need to be inside this particular hole. The first dimension is your diameter. It needs to be 5/16 of an inch. This next dash here might say 5/16-18, 5/16-20, 5/16-24. This is how many threads you'll have per inch. So the higher this number, the more fine your thread, the closer they are together. And then down here you have different kinds of threads. You can have a coarse thread, which is done not so precisely, or you can have a fine thread, which is very thin, very fine, very attention to detail. And so if it's a fine thread, it'll say UNF. If it's a coarse thread, it will say UNC. So this one wants a coarse thread. So let's go to Inventor, and let's try to make a hole on a point. Let's pick this point and the direction that I want it to go. Okay, and then I'm going to say that I want it tapped, because now I want to put threads inside this hole. So I come down here to the bottom and I say tapped hole. And we still can thread it all the way through or thread it only part way through. This one, we're going to go ahead and thread it through all. And I just want a regular hole here. I don't want countersink. Notice whenever I had it as a regular hole, the box was smaller. When I pick a tapped hole, then these choices come down here. And we want unified screw threads, because this is UNC, unified. The size that we want, I can come over here and look at this designation, and I'm going to go to this drop down box, and I can find designations. I want my size to be 5/16, which is 5/16, maybe right here. Oh, nope. See, notice this says 7/16. So you can divide it out on your calculator too. I'm just in a hurry today and not doing that. What did I pick? 0.4375. So I want this one. Let's see. Oh, that's 3/8. Nope. Well, let me get my calculator out here really quick. Sorry about this. I'm trying to hurry and get through this, and I didn't think about needing to have this divided out ahead of time. 5 divided by 16. 0.3125. Didn't go small enough. I was going the wrong way. Here we go. And then notice when I get the decimal right, it changes this right here. And then you have choices. You can have 18, you can have 20, you can have 24, you can have fine thread, you can have coarse thread, and so forth. So this is what matches what's on my drawing. So this is what I'm going to pick. And then I say apply. When I close it out, notice that I have cleaned this up. When I look into it, you can see the little ridges in there to show that it has been threaded. So that's the English system. Let's look at a metric system. Metrics are a little bit M for metric. 12 means you have a 12 millimeter diameter. So that tells you your diameter. This is the pitch of the threads. So we have 1.5 threads per inch, or well, per centimeter, 1.5 threads per centimeter. And then the 6 stands for the grade. So again, in the English system, we said coarse or fine, but now in the metric system, we go anywhere from 3 to 9, and that represents the grade. H means your allowance. H means no allowance, so it's not a clearance hole. G means a tight allowance. And then this is telling me I want it to go all the way through the hole. And if you see an LH and then a through, that just means you want a left-hand thread. So this is what metric looks like. Let's put one of those on our part in Inventor. So again, you know the drill, hole. And we want to do it on a point, and we have 1 point left, and we want to do it in this direction. And when I look at my thread notes, this is going to be metric. So I come down here and I say isometric profile, and then, oh, nope, I want, oh, ANSI metric profile. And then I want M12 size. I want it to be 12. And I want it to be by 1.5. So I picked M12 by 1.5 so that it's matching what this thread says over here. And then the class, see here's my 6H class, which is really common, and so that's why you see the 6H, and I want it to go all the way through. So I pick the threaded, I tell it right here, my termination, I say go through the whole piece, and then I apply. Close it out, and I'm going to clear out my final point, and then we see that it threaded the hole right here, and it made it a 12 millimeter diameter, so I didn't have to pick it when it was threaded. It already made the hole that size. So I hope you kind of got an idea about how to do holes and threads. I hope that there's like a lot to know, but it's really easy stuff to know. And if you need some help, please don't forget that you do have Inventor experts in your class that have been studying holes and should be experts on them. So find them and get them to help you if you need it. Following this video, we do have a small exercise, so go to Blackboard and you're going to actually make a part and put several holes into the part so that you can practice what you've learned here today. Goodbye.